good evening. Got a busy day here. We got some beautiful sunsets here in this part of Texas, don't we? A little bit of tropical moisture, though, kind of blocking the view towards the end there. But we can see it there on the soundings there at Fort Worth. This is this morning's Fort Worth sounding at 12Z. And you can see the moisture right there in green, extending from the surface on up to about 5,000 feet. And one measure of the richness of moisture is not only the depth, but the absolute humidity. And we can see that up here at the top. We've got that calibrated in grams per kilogram, and we're seeing about 11 grams per kilogram of moisture about 5,000 feet deep across North Texas. And we're going to look at that 11 grams per kilogram value in just a little bit as we get a little bit further. Skipping right ahead, let's check this out. The Weather Service watches and warnings and big red flag advisory all the way from the northern Texas panhandle up to Nebraska. Out ahead of that, we've got severe thunderstorm, or actually tornado watches out ahead of that right in this area right here, and a few tornado warnings from about Kansas City up to Des Moines. And we'll take a look at the SPC chart here and look at the overview, and you can see we've got an enhanced risk out for the western Midwest area, Missouri and Iowa. So not quite a moderate risk or anything like that, but definitely some severe potential. And there you can see the watch boxes all the way from Minneapolis down to about Tulsa. And here's the storms looking at GR level 2. And we're focusing specifically here on the Kansas City area. And here we see pretty much a solid squall line all the way from up and down that area of watch boxes there. And zooming in on Kansas City right here, you can see the line is broken up a little bit. There's a little bit of discreteness there, so it does bear watching. And here we've got a little bit of a supercellular look to this cell right here in eastern Kansas City. And the rest of the line, it's also kind of got that broken appearance, especially up here. This is getting out of the range of the radar, but you can see it's got one area where the line is kind of bowing ahead. And so we're kind of like on guard for possible supercells picking up in this line. There's not a big potential for that. And also QLCS tornadoes, which would be quasi-linear convective system tornadoes, those can certainly spring up at any time. And we're going to expect to see that kind of like die down as the evening goes on. Usually that's what we see. The nocturnal trend is for that to die off a little bit. But still, we've got this tornado watch right, or tornado warning right here. And there it is on the screen right there, Cass, Lafayette, Jackson, Johnson County. And that's going to be radar indicated right there. And let's see if we can pick that out on the velocity products. Here's a storm out of velocity, and you can see a pretty clear demarcation between the outflow and the inflow. And let me draw that out right there. So out here you can see the environment is kind of red. That's going to be flow away from the radar, so pretty much going this way. In fact, if you want to get precise, you can find the zero line. Looks like maybe it's right in here. So we're looking at the inflow kind of going like this right here, right into that line. And up here we've got the outflow. And maybe we can see that on the spectrum width. This is a good opportunity to use that. And yeah, it looks like we can kind of see that outflow boundary like that. Let me set a dot right here. I'm going to place a marker right there and see how that matches up to the reflectivity. So we can see that maybe there's a little bit of outflowishness to this cell. So maybe something like that. Let me back over to the spectrum width again. Yeah, so there's a little bit of outflowishness to this cell, and the more outflowishness we have, The cooler the downdrafts, the more we get undercutting of the updraft. The updraft bases in this area, and that would diminish the severe weather potential. But we still, of course, have this tornado warning out for that cell. Let me go back to the storm relative velocity and see if we can see any tight circulations. There's a little bit of a very strong outflow right in this area, but we don't see like a classical couplet with that storm. And I'm looking all down the line right here. Yeah, we're not seeing anything really standing out in that. This right here, there's a little bit of very strong outflow in this area here. But, you know, this is getting way up there. This is up at probably about 6,000 or 7,000 feet. Let me get a reading on that real quick. Yeah, that's going to be up at about 5,000 feet. So that's getting into the cloud base itself. Okay. And we're going to come back to this towards the end and see what the storm is doing. And let's check out what's going on elsewhere across the country here real quick. These are the high temperatures for today, and you can see we've had low to mid 80s in Texas. This has been kind of an ongoing thing. And let me show you the temperatures at DFW over the past 3 months. Yeah, look at that right there. This is the normal high, and this is the normal low. And you can see for the past 60 days or so, temperatures have been well above average. And in fact, out of 57 days, we've only had 3 days below normal. So, I don't know, that's a bit ominous right there. Hopefully that's, I don't know, we get into some discussion of global warming and that kind of thing there. But yeah, this has been a very unusual winter. The median temperature departure is about 8 degrees above normal, which means we're pretty much running at about the normals for early April right now. So about April 6th or April 7th, this is the type of weather we usually see in this part of Texas here. All right, move on to the 500 millibar chart, and this kind of shows the picture of everything that's going on right here. Trough to the west and ridge to the east. And when we're chasing, that's a pattern we definitely like to see. Jet stream coming out of Las Vegas to Flagstaff into the Four Corners, and then coming out over the Goodland, Omaha, and Minneapolis area right there. So this is the storms we have in Kansas City and Iowa. They're very close to that axis of that jet right there. Here in Texas, you can see we're pretty well south of the jet. There's still some 30, 40 knot flow, but this is what we call being on the negative inside of the jet. So we're equatorward of the jet, and this is where we get some transverse circulations that favor subsidence. And if we go back over to the SKU-T, we can see in the mid-levels we've got quite a bit of warm air up there. So you see that right there. And that kind of reinforces the capping that we have in this part of the country here with this particular situation. So if we were to try to lift this parcel with the afternoon highs, like maybe 88, we would be going through a little bit of capping in here. And then not much cape. The only cape to be found is way up there aloft, up near 20,000, 30,000 feet. So this isn't very conducive to severe weather. But let's see what the parcels are doing closer to Minneapolis, or closer to Missouri and Kansas. This is the Springfield sounding here. And remember, we were seeing about 11 grams per kilogram for the Fort Worth moisture. Springfield running about 10 right there. So if we lift this, we get kind of a weak bit of capping right there. And some fairly decent cape, 1,000 maybe, 1,000 to 1,200. But very steep lapse rates there from about 700 up to 500. And let's check out Topeka. And that's where the severe weather action is. And you see the lapse rates are a lot steeper out there. So probably this is going to be representative of what the mid and upper levels of the atmosphere has at Topeka. The low level is not very representative, but we can kind of modify the sounding and put on that 10 to 11 grams per kilogram and draw that on real quick. And so this is probably what we're seeing for proximity soundings around the Kansas City area. So you go a little bit further north from Springfield into the I-70 area, and instability goes way up, and that's some pretty decent CAPE there, 3,000 joules per kilogram, and very steep lapse rates right in here. This is the 850 chart for this morning, and that shows a little bit of the low-level jet we had this morning. And you can see I'm using Canadian charts here. I kind of like using different stuff, different sources, kind of blend everything together. And this is about what the low-level jet is like, running from western Oklahoma through central Kansas and up to Omaha right there, bringing the moisture north and northeastward. And then the 700 millibar chart, this can kind of give you an idea of what your cap is doing. So this is 12Z, so this is a lot earlier today, but this would give you an idea of the setup that we had earlier this morning. So let me see, let me draw a 4 on here. And then, let's see, 6 would be like that, and our 2 line would be something like that. So this would give us one way of visualizing the cap that we have during the morning hours, and then of course that will change as the day goes on, and for that we can look at the NAM and GFS to see how that changes during the day. You don't really want to advect these because that doesn't take into account dynamic lift. That's going to certainly change the field quite a bit. But this can give you one way of checking out the GFS and then AM to see if they're pretty much on track with the temperature field. Okay, let me go over to the chat, see what's going on. Got quite a crowd here this evening. Adam checking in here, and let's see, we got Andrew, Michael Burrell, Brett Dean, Ryan Toomies, Michael Burrell, everyone in Indiana, please take note of the storms coming your way. Tracking some intense storms. Okay, Alexi, Ron, and some Arabic, I can't really see here. Adam Davis and Jason Boggs. Big wildfires in the Texas Panhandle. Yeah, got a big red flag day here. Fred Reamer up in North Dakota watching the storms. Sue M. and Fun with Tech is checked in, and Andrew says low-level clouds flying out of the south this morning across central Illinois. So yeah, that's probably that low-level jet coming across. Eddie W., I think that's a new name. Can't remember for sure there. Ryan Toomey says this summer will be brutally bad. Man, I hope not. So the last thing we need is a hot summer after this. Okay, so what's happening with the upper level patterns? This is one site I've been kind of looking at over the past week or so. This spc.noaa.gov EXPER. And you click on that and go to this upper air maps. And I kind of like this because the maps come out very quickly. So this can give you a very quick look at the upper air conditions after the 0 and 12Z hours. So for example, this is the 850 flow just 2 hours ago. And so we can get kind of an update on what the low-level jet is doing. We can see it's in place kind of like this. Maybe even flowing up into central Illinois, like what Andrew, I think that was Andrew, what Andrew was saying. Yeah. And we can also see the front coming out of the Central Plains right there. So you see these dashed lines here, those are going to be your isotherms, And that's going to be your 850 front right there, from about Omaha down to Wichita and down to Amarillo. Satellite looking like this, and you can see those very strong storms up in the Kansas City area right here. And we also see the cold air and the cold stratus coming out of western Kansas and Nebraska right there. So this can kind of help delineate the front. So maybe like that, or perhaps even like that, one of those two. But this is a very cold boundary, and let me show you that on digital atmosphere here. This is the surface plots. And you can see the front coming through Kansas City right like that, and some very cold air back behind it. And when we get cold air behind a boundary like this, that tends to favor linear storms, linear modes of development. So if we were to look for supercells, classic supercells, we would really want to see less of a temperature contrast across this front. So this is going to act kind of like a wedge as it moves eastward during the evening hours. Okay, one other way we can look at these storms is on McItis, and let me pull that up real quick. I was on here looking for GOES-R imagery, and I couldn't find any. They've got that sequestered from the general public, but we do have the regular satellite imagery, and you can see the very cold tops here. And when you don't have radar data, you can kind of use this to find where your stronger cells are. You just find the cold tops. So maybe there's a top right there, and you can kind of use this to kind of isolate where your stronger cells are. And we can follow that down and kind of see where the cold front is. So maybe it's running something like that right there. And you can see the warmer lakes in here. That's either lakes or wildfires, one of the two, showing up pretty well right in there. See those little hot spots right there. Okay, let's see here. I'm getting kind of lost in all the charts. Let me see what we're going to cover next. Yeah, let's do our thermal analysis, kind of get back to reality here. Thickness. You can see a lot of thickness packing there across Kansas and Nebraska. So that's your thermal gradient, and that's outlining where your cold front is. So something like that. And we can track that all the way back into the mountains, where it's hard to analyze data. And this can show exactly where that front is way back there. The main warm front, well to the north, way up in Ontario. And remember, yesterday we had kind of a boundary in Texas, kind of like this, that lifted northward overnight. I would probably be looking for that maybe here or maybe up in this region. So we'd probably want to use some continuity to find where that boundary is, because that could be a factor with the storms that we have this evening. Let's see, is that front showing up? Now, one way that I like to analyze these fronts when I'm doing a search for them is I look way down south at the air mass down here and kind of see what the values are, and I can see temperatures 75, dew points around 67. Okay, so mid-70s, dew points in the mid-60s maybe. And then I compare that with conditions further north. So maybe up in Illinois, I can see temperatures are in the lower 60s and dew points in the upper 50s. So where's that transition taking place? So I'm going to kind of look along this line and maybe do what I call the imaginary car drive, and drive from maybe Dallas up to Tulsa, up 75, and maybe up I-44. Where do I hit that front? I kind of suspect it's going to be maybe in this area right here. So maybe I'm going to look for kind of a weak warm front, perhaps in this area right here, out ahead of this cold front here. So that can be one area to watch right there, that triple point. Maybe not doing anything right now, but if we had like a lot of heating, if it was earlier in the day, this could be an area of cyclogenesis right there. This is a baroclinic area, And that's certainly ripe for cyclogenesis right in that area. Yeah, and that matches up pretty well. 76 there in Oklahoma City, dropping off to 65 around Batesville, 66 there. So, yeah, that's one boundary right there that you would look for also. Okay. All right, what else do we have here? Yeah, dynamics. Let's check that out. This is the 500 millibar vorticity, absolute vorticity. And we use absolute vorticity because, yeah, we have relative vorticity, but that's just the pure wind field. Absolute vorticity factors in the planetary rotation, so that's kind of like everything all put together. And this is the classic vorticity that you look at when you see upper air charts. So this is the pattern we have right now, and you can see high vorticity right in this area. That probably corresponds to maybe a little bit of a jet streak right in that area. And most of the lift is going to be right out here in this area. This is where we have the strongest cap removal and the strongest instability in the mid and upper levels. And then the main jet itself, that's going to be running kind of like this right here. So what's going to be happening over the next day or so? Let's run that forward. You can see that main slug of vorticity moves up into the Michigan area, Lake Michigan to Wisconsin. And then by evening, by the time we do the webcast tomorrow night, that's going to be up in the Detroit area, South Bend, Toledo, kind of in this area right here. And then we're going to have ridging coming in back behind that. Right there, that's some ridging. So that's going to warm things up for this part of Wyoming and Montana. Let's see, moving forward to the rest of the week, zonal flow setting in. Polar front jet pretty far to the north, as we would expect in April, which it seems like it is. A couple weak waves going through the flow over the weekend. That's kind of new. I don't remember seeing that on yesterday's chart. That wave kind of descends, moves into the Missouri, Illinois area. But I think the main front will have pushed southeast, so we're not going to have much moisture with that, I don't think. A couple waves moving through the flow, and then the next big system coming on the west coast early next week right there. And then we get back into a pattern of long wave trough to the west. Big long wave trough here with smaller scale waves working through the flow right here. Okay, so I think we're about ready to head into the forecast here, and let me get the chart set up. And this is from Pivotal Weather, and I appreciate the use of their charts there. They've generously allowed us to use this for the meteorology lab. And let me go over to the chat one more time and see what's going on. And after this, we will look at the radar for Kansas City and get one last look. Sue M. saying, wild rumors that southern Indiana will get 9 inches of snow this weekend. We'll have to watch for that on the GFS. Michael Burrell mentioning it'll be the majority of Indiana. And let's see, Ryan Toomey's much warmer temperatures, Florida the same. Okay, yeah, I think I'm looking at the same chat here. Okay, so let's go forward and see what's going on. There's the front this evening. And for our webcast tomorrow, we're going to see these patterns move eastward. And there we go. The front's going to pretty much run from, looks like maybe around Buffalo to Charleston, down to Atlanta, and down to the Houston area. So kind of like that. Some dry air, cooler air moving back in behind that. And remember the thickness packing outlining the front. Looks like we've still got some of that going on out west. So possibly a new system developing out in Idaho and Oregon. Then for Wednesday's webcast, looks like kind of a quiet day. A little bit of high pressure moving southeastward like that, and low pressure redeveloping out in Colorado and Wyoming. So we're watching this Pacific system, seeing if that tracks eastward along this frontal boundary. And indeed, let's see here, by Friday evening, frontal boundary kind of acting like a backdoor front in here. And I would actually say the tail end probably goes something like that, maybe, because we got this packing of thickness lines like that. This is probably the polar front right there. And this is the triple point right there. So this is the main baroclinic zone where we're getting development, and looks like a little bit of upslope starting to get started up in South Dakota, North Dakota, out in this area here. And that starts moving eastward over the weekend. This is Saturday morning. So there's the warm front, cold front looking like this. And so this is the main cyclone right here, 850, probably looking fairly similar. So we're actually bringing moisture up from the Gulf, up and over the front, kind of like this. So that's helping to fuel this area of precip around the Omaha and Des Moines area. And then things, of course, move eastward. GFS carrying that off across the Mississippi River Valley into the Nashville area by Saturday night. This is 6Z, so this is going to be about midnight, just after we do the webcast on Saturday. And actually, you can see a little bit of cold air damming in Virginia and North Carolina. So the fronts are looking like that. What's happening is that there's cold air in place right here. It's trying to flow around this cold air, around this, low pressure area, but it's getting blocked by the Appalachians right there. So as a result, we see this kind of kinked appearance of the warm front, kind of like that. And the snow line stays kind of far south in Virginia right there. So yeah, a little bit of snow there, especially in southern Indiana. And then that moves off very quickly to the east. High pressure moving in back in behind that. And then very quickly next weekend, next system coming south. There it is right there. Mostly a weak Canadian system moving southeast. And then by Thursday and Friday, looks like another weak system coming across here. Not much going on for Texas, but looks like more rain for California right there. New system coming on shore there for the 15th and 16th. Okay, we're 29 minutes in, so let me just take one more look at the radar for Kansas City. Still got a tornado warning in effect for that same cell. And what I like to do is check and see what the source of that is. A lot of times it's radar indicated, but it looks like we have weather spotters confirming a tornado on the ground right there. So that's going to be near Oak Grove. So let's see if we can find that. There's Oak Grove right there. If we allow for maybe a little bit of latency in the warning, that's probably the cell right there. And let's see if we can find that on the storm relative velocity. Yeah, some very strong. See right there, some. Looks like we got about 46 outbound from the radar. That's in this direction. And then we got about 37 in. So that's going to be kind of like a very tight couplet right there. Let me put a dot there. So yeah, it's going to be actually embedded in this thing right here. Spectrum width even showing a little bit of diversity there, so maybe a little bit of debris embedded in that. And let's backtrack that just a little bit, see what that looked like a few minutes ago. So we're looking for time consistency. There's the couplet right there. Back that up one more frame. So there we go. We can actually use this to predict the forward motion. So let me drop a dot right there. And I'm going to go forward to the current time. And Let me resize the window so you can see what I'm doing here. You notice that I have this readout down at the bottom. This shows the azimuth and the distance from that dot. So when I put that right on the dot, you can see it's reading 0. So if I move this forward to where the couplet is now, you can see we've got a motion of about 090 at about 5 miles over those 4 frames. So we can actually use that to project the forward motion. So if you have street level data, if you're watching a spot right there, you look at that and you see, well, we've got 090 motion on that. That's right along the track. So you're going to expect the tornado to pass right through there. Okay, anything else going on up and down the line? Looks like not really. Yeah, it looks like the rest of the line is starting to subside a little bit. But again, we're watching that cell right there along Interstate 70, moving eastward. And hopefully not too much more bad from that storm right there. All right, appreciate you all watching. That's probably going to be it for me, and I will be here at the same time tomorrow, 8 o'clock. Thanks for watching, and see you tomorrow.
Mm-hmm.